in another direction. Okay, let me take the next condition. Yeah, we have diagram. Arrow reverse. Okay, now there's a parallel beam of light. This axis. We don't know where central maxima will be. Let me take it out, this one. And this slab also will not be there in the picture. Oh, so many things I have to change. Okay, get into this one. So some description is what I made. Okay, this is the condition S1 and S2. These are this. Some rough diagram is what I have put. So let this be monochromatic ray of light. So let it make an angle alpha. So the particular beam of light is not illuminating it normally. This ray, let it be there. So now again, you look at this triangle. O will cover more path, so this will be delta x2. Try to make observation. I'm putting some information here. This is thing. Okay, this is theta. We'll carry on this one. What to do? We have here alpha. I should search for that conditions here. So this should be the alpha, because here this alpha 90 minus alpha. Then this should be the alpha. See, like ensure this, if he has given an angle made by the incident beam with the plane of the slit, so then it would have been, the alpha would have been here. So try to notice that one. It's not that don't memorize formula now. No, you should focus on the what is alpha. Alpha is the angle made by the incident beam of light with horizontal. Instead of this, you may say like that the beam is incident at an angle alpha with respect to plane, with respect to vertical plane in which slits are present. Means is asking, it's referring with respect to this. So he will not give diagram, he will explain the condition. So you must able to imagine things here. Now the net path difference. So O will cover more path before slits, the ray passing through the slit S2. O will cover more path after slits, again the ray 2. So therefore the resultant path difference should be equal to, I'll add up. Earlier we took the difference. So now what happened? We are going to add up. So delta x2 should be equal to d sine theta. Delta x1 should be equal to small d sine alpha. From the previous problem, so I'm writing the content directly. So this will be net path difference. So n lambda d tan theta d sine alpha. What is tan theta? Y max by d. Okay, so this is the expression for the nth order maxima on the screen. where the central maxima will lie below or above the axis. So should lie below the axis, the central maxima. Put n equals 0, y max equal minus d sine alpha. So from the data, so somewhere here, central maxima, I'm placing it. So position of central maxima should be equal to minus d sine alpha. Now, any other thing? What is the order of interference opposite to slit S1? So we'll calculate that one. Y S1, I'll write it. This should be equal to, what shall I do? where I should, order of interference I want. Order of, let me put that one. Order of interference opposite to slit S1. Let me write for both. Yeah. How to do this? What is the value of y for exactly opposite to slit on the screen? What is the order? So what shall I do for this? So what is this distance will be? This should be equal to d nu, small d, s1, s1, s2. I'm unable to indicate in the diagram. It'll be, oh, I'll get you the screen. I'll get you the screen. I pressed the wrong one. Uh, are you able to view the screen?
Yes, sir.
We'll continue. Lot of problem. Some gap came, no, the buttons. Okay, no. Now see this order of interference opposite to the slit S1. So exactly opposite to slit, what is the distance? This should be equal to d by 2. So this order has to be determined. Now we'll take the, no, so this should be, what shall I write in place of y max? So plus d by 2 is equal to n s1, I'll write it. Any symbols you can give. So d minus d sine alpha. So this should be equal to, so therefore ns1 should be equal to d square by 2 lambda d. Check it, final equation, is it correct? ns1 should be equal to d square by 2 lambda capital D plus d sine alpha by lambda. Capital D gets eliminated. Okay, this should be the order of interference. Substitute all these values, you'll get the order of interference. Similarly, I want order of interference exactly opposite to slit S2. So what has to be done? Put minus d by 2. Then you'll get ns2, means order of interference exactly opposite to slit S2. Able to make it to the condition. So I can ask you anything here. So you should be in a position to find out order of interference at any position. Okay, so now what has to be done to bring the central maxima at the axis? Back to the axis. It should be there at the axis. So the beam of light is incident at an angle alpha with the axis. Monochromatic beam of light is in at an angle alpha with the axis. And the central maxima must be here. So where the slab should be introduced. So I think better we'll think technically like this rather than. So let me give the fresh diagram. So this is the. I totally forgot all the shortcuts. Huh? Oh, no, this is the beam of light. No. So for finally, what should happen? So the ray, both the rays, they should form, and the central maxima must be somewhere here. So this was the alpha S1, S2. Which ray will cover more path before slits? The ray 2. And now if I increase the path length of the ray 1 such that how much of additional path the ray 2 covered before slits, that much of additional path the ray 1 covers after slit. Definitely the path difference of the rays arriving here will be 0. Then there will be central maxima. So what is the central maxima? So where the central maxima will located, where the path difference of the rays coming from the slits, if it is equal to 0, there the central maxima will be located. Able to understand this? This is something very important. What do you mean by central maxima? So where the path difference of the rays emitted by the slit, if it is equal to 0, then that is the location of central maximum. So I should increase the path length of this. So I should bring now the slab here. So what is the additional path? So delta x1 should be equal to mu minus 1 into t. So this should be equal to this should be the thickness of the slab. Okay, I think hope everyone is able to manage things very comfortably. Now the slab is there. Yes, sir, I'll manage. Okay, now what happens if student accidentally, if he, instead of placing slab here, if he places here? Can happen, no? In lab, but maybe well, students, what happen? He may do like this. Okay, let's see what we'll get it. No, by chance, if he places slab here, any changes will come, or okay, sir, no, nothing as usual. Central maxima will be there at the axis. I want answer from any one of you. Anybody interested, you can easily reply back to me. That chart, I think I don't know. Okay, chat, I'll check it. Yeah, it's there. No change. Huh? Okay, Sai Surya, no change. Anybody? Gunetra, no change. Anybody still? I can read chat. You need not to interested. Okay, you can reply. You can explain, or you can put in chat. Sushant Reddy, no change. Sriman, no change. Others present or only just switched on mobile. You can reply. Think on it. No, sir. Delta X will change, so it should change. What Gunetra? So why two replies? No change. Again, you're telling will change. Shift down. No change. So I want you to think of, because this is very important. If I don't permit, if I just go, if I wind up and go no, so definitely in exams I may ask this such things. It will change. Neha, no change. Charvi Palam, shift down. Ansika Reddy will change. Sri Sheshta, this will shift. Gayatri Devi, it will change. Okay, 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 fine, fine. So you are expressing your views. Shiva Prabhat, it will change. Oh, okay. Shiva Prabhat, why it will change? Please explain. Shiva Prabhat, unmute and tell me why it will change.
Sir, the first path ray will change. First source, the where the light is entering, that they you can put the slab.
No, how much of additional path the ray 2 covering, that much of additional path length is offered by the slab. Then
So, but there will be a change in path length.
nothing. So it is assumed that it will be incident normally on the slab. And the position of slab will be like this. It has become a practice of showing slab like this. The slab will be oriented in this way. It has become a practice of just putting rectangular slab vertically. Okay, got this one. So thickness is very small, no? So though it is incident at angle, just we can neglect that orientation. So if I put a condition, I'll put a condition clearly. How much of path length the ray 2 is having additional path length, that much of additional path length is provided by the slab before slits. Then before slits only, the path difference between the rays is 0. Anyway, after slits, the path difference is 0. So center of mass will be there at axis. Is it possibility? It will remain same now. Okay. So if I put a slab, center of mass may shift up, may shift down, may not shift. The reason for that, it all depends upon thickness of slab. If the path length, if the additional path length of the ray 2, if it is equal to the path length offered by the slab to the ray 1, then center of mass will not shift. Okay, got this. So since I put center of mass at the axis, so therefore what is the conclusion I should make it? The delta x1 again should be equal to mu1t. Okay, this will be mu1t. What is delta x1? This is equal to d sine alpha. Usually it's a practice of pasting the slab, the thickness of slab. Anybody, can you make a guess of thickness of slab? Micrometer. So what I do, I just do like a thin sheet of like a paper, it will be there, no? That the glass sheet, I'll just paste it here. So you can paste it, but usually practice of pasting it here only. I'll not, if I put slab here, again I have to bring a stand to hold it, the pattern will not come. So what we do, just I'll take a glass sheet of order micrometer. I think it will be very thin, no? Glass sheet, this one. Or even it can be made up of plastic where I can adjust the value of mu to certain value. So that plastic sheet, I'll stick onto it here. That is enough. So this is what happens. So it's like in books, what happen, we are just showing slab here or here, not in a lab. What happen, I'll take the sheet, I'll going to paste it here, where all I want. I can paste it here also, but usually the practice of pasting it here only. So even if it's slab comes here, doesn't matter. Now if the slab absorbs some light, okay, it makes some difference. The dark region will not be completely dark. Then be very difficult to notice the dark bands. The pattern will not be distinct. This is what happens here. So we are assuming that the slab will not absorb any energy. Okay, this is okay. Let's bring other conditions. Why it is so big? Okay, I'll start the, let me, in the same situation, let me introduce the